Hello everybody, welcome back to another video. We haven't had one in a while. Today we're going to finish up the rest of Unit 4 that we decided not to put on the test. It is on direct variation and inverse variation. So today we're going to do direct, next class we're going to do inverse, and then we're going to do our little e-cart to make sure you guys understand it. Okay, let's start. So direct variation, this seems wordy, but go ahead and pause the video for it. Is a linear function, meaning it's a line, defined by the equation of the form y equals kx, where k does not equal 0. Okay? That's what direct variation is. The constant of variation is a non-zero constant, so a number, k, in the function y equals kx. So the equation looks like y equals some number times x. Okay? Very, very similar to slope-intercept form, except there's no intercept. Okay? So k is a very special kind of slope. It's not exactly slope. I don't want you calling it slope. I want you calling it k, or a constant of variation, because it's very specific for direct variations and inverse variations. Okay? So a direct variation formula is y equals kx, which you guys already have. So we're just reiterating that. The direct variation constant of variation, so the constant of variation for a direct variation, wow, is this. K equals y over x. Basically, I just took the direct variation formula and got k by itself by dividing everything by x. So the way you would get k is you would do the y value of an ordered pair divided by the x value, and it would be your k. And that would be the same for every single point on the direct variation. Okay, so direct variations are lines that travel through the origin. That's why they don't have a y-intercept. That's why we don't use y equals mx plus b, because the b is 0. Okay, and we just change the m to a k because it makes it special. Alright, so example 1. Is this a direct variation? Y equals 6x? Well, yes. This is in the form y equals kx, where the k is actually the number 6 here. So this is what it would look like. X over y equals 1/3. Well, we need to get y by itself first. So it's in the denominator, so I need to multiply by y on both sides. So now I get x equals 1/3 y, or y over 3. Then I can multiply by 3 on both sides, which gives me y equals 3x. So, I don't know why I wrote it twice. Yes, that is a direct variation, or 3 is the k, because it's written in the same form, y equals kx. Alright, you're going to try these two on your own. Ooh. Okay. X equals y over 2, and x divided by 4 equals y, and see if they actually come out to look like y equals k would be a number times x. Okay? I'm not even going to scroll. I do need to scroll, don't I? Oh. Yeah, let's see if example 2 is on the next page, because I accidentally forgot to blur out the answer for this one. Yeah, I don't have to show you the answer. Woo! If you need to go back, go ahead and pause the video, but we're trucking on through. So suppose y varies directly to x. It tells you it varies directly, meaning it's a direct variation. Okay? And they tell you y equals 3 and x equals 2. So they basically gave you an ordered pair here. They want you to find the x when y equals 6. So, that's the answer. Let's find out how to get there. So varies directly means that it's direct variation. So we got y equals kx. The only thing we need is k, but they didn't give that to us. So we're going to find k, and we're going to plug in the x and the y that we know match up together, the 3 and the 2. Plug that in, and we just solve for k. So I divide by 2 on both sides. I get k equals 3, 2. So our equation for this specific problem is y equals 3/2 x. So I go ahead and I'm just going to plug in the y for it and solve for the x value. So 6 equals 3/2 x. To get rid of that 3 halves, I can divide by 3 halves, or I can multiply by the reciprocal of 2/3. 6 times 2/3 gives me 4. Where did I put it? So x equals 4, and that's my answer. Okay? You guys are going to try this one on your own. So it varies directly, meaning it told you it's direct variation. So start off with your general form of direct variation. Make it specific by finding that specific k, and then you can plug in your information to find it. It's actually kind of similar to line of best fit in a way too. You got to get the equation before you can find what's missing. Okay? So go ahead and do that, and we'll move on. So example 3 is we write the equation for the line when it's direct variation, okay? So basically, when we have direct variation, you know it's direct variation because it's a line going through the origin. That's how you can tell it from a graph, okay? So I'm going to move this guy in the corner. So basically what we're doing is we are finding, you could do the slope, you can do that. Or instead, what you could do is you can just do the same way we find k, because that's all we need is k. We do y over x, so 6 over 5, and that's our k. And if you wanted to do slope-intercept form, you could do it because that's also the slope. But y equals 6 over 5x is our equation. So you're just doing y over x for it, because that's how you find k, and that's all you need for the equation is that k. So all you need is 1 point, you can find k. Unlike slope, where you need 2 points. With direct variation, you only need 1 point to find the k. Slope, you need 2 points to find slope. So that's why it's a little bit more special. So this one, you're going to write an equation for the line. So you want to go ahead and figure out, you can pick either of these points, find the k, and get the equation. Or you can do slope-intercept form. Okay, when in doubt, you can do slope-intercept form. All right, so go ahead and try this one on your own. Did it come out nice on your thing? Nice-ish. It's okay. So this looks like it's a 3. The x is 3, while the y is 2. This one, x is -2. This one, we're gonna assume is -4. We'll see what happens. Doesn't look like the prettiest graph, but we'll go with it. And then example 4, they give you a table. So very, very similar to, what was I saying? Very similar to how you do it with a graph. You want to find the k for each one. Now, here's the problem. We have to determine if this is actually representing a direct variation. In order to determine that, we should be able to find k the same way for each point and get the same number. So remember, for a direct variation, y equals kx. To find k, you do y over x. Okay? So this isn't even asking for the equation, it's just asking if it's direct. So we have to do this, and we should get the same k for each ordered pair. Okay? So we do y over x for each ordered pair. So this one, 4 over 1 gives me 4. Next one, 8 over 2 gives me 4. 12 over 3 gives me 4. 16 over 4 gives me 4. So because I got the same k, constant of variation for each point, that tells me it's a direct variation. Okay, so where the k is 4, so I would write my equation y equals 4k, or 4x. That's why it's special, is that you don't need 2 points to figure out the slope. You only need 1. Okay, and then it should be the same thing for every single point. Alright, so you're going to try this one on your own to see if it's direct variation. So you need to test it to find out if it really is. And that's it. Okay? Under a 10-minute video. Go Miss Scully. I'm awesome. If you have any questions, write them on the side. We will go over them next class. Okay? But I'll see you later. Bye-bye.